So in case you got a 263 HD or 261 series transfer case and she shits the bed on you, you get into wanting to rebuild it and you run into this problem where this hub got all wore out and scored this shaft real bad, and you can see the grooves on that hub. I'm going to show you how you can save this shaft and this hub, which is quite a bit of money, and then you only have to buy the normal rebuild kit and plus the few other parts that might have failed. But I mean, you'll save like a $200 shaft here. I've done this on a couple and it's worked. I haven't had one fail as a result of doing this yet. And on a side note, to show you quick here, I seen this on this transfer case. Someone actually fixed the rub problem with JB Weld. I've not seen anybody do that yet. And you can see there too, there's actually a fingerprint in this one. But it rubbed into the JB Weld a little bit because they didn't do the update plate. But it held. That was not the cause or failure of this transfer case. What ended up happening is this snap ring groove back in here for some reason wore out, and the bearing was able to come in and out, and then when the shaft would come in, it would cause the chain to come and rub on this shift fork and threw a whole boatload of metal into it. And you can see the boatload of metal. Plug the oil pump. And when the oil pump plugged, then this failed because it wasn't pumping any oil to lubricate this. So, fun. But just in case anybody has to do it on their own and wants to try, this is the first one I've ever seen anybody do it to. But hey, JB Weld can fix the pump rub through, at least for a little while. So, worth a try. I'll zoom in on there again just to try to, you can see. Alright, we're going to fill in right in here with some MIG braze, kind of like how I built up this other shaft here. Then we'll turn it down the way so we don't warp it. Got some damp rags here. And wrap it around spots. And it also keeps, since this braze splatters a lot, it keeps the splatter off. And make sure you don't get too much heat into it. Alright, so we're starting with the hub. It was all tore up as we already showed you. Chalk it in your lathe. Make sure she's nice and true. It's true, even if it appears not so, because I might be shaking the camera. This would be a lot more ideal on a bigger lathe, because I can only go in 3/4 of the way, and then I'm going to have to flip it and get the other side because my bit isn't strong enough to stick out that far. If you got a bigger lathe, you can get a nice heavy bit and go in full travel. Another thing I've done, this one's tore up real bad, but if they're not tore up real bad, there's just a little ridge in there, you can take an engine hone and hone them out level, and boom, super fast, that's done, and it's true again. You just want it to be one universal ID size. Don't worry about how much you take off. I mean, for the most part, obviously if it's like really wallered out, but don't worry about how much you take off. You just want it to be true the whole way through. Hear how uneven it is worn there. You hear it kind of cutting, and you hear her back out as she goes in there. Now it ain't even touching. Now you can hear her biting in again. It'll take quite a few passes here to level her up, but we'll get her. Alright, we've made a few passes. You can see here, we're getting her cleaned up. You can see our high spot right here. Thing you got to worry about with these cheap piece of crap Harbor Freight lathe bits is if you got too big of a high spot, like it's taking material off here as you can see, but this center spot where there was a groove in the shaft for the oil to run, it didn't wear the hub that much there. So there's a lot of original material there. Well, it had a big bump to jump over there. Well, instead of cutting it like it should, like a good lathe bit should, this crappy lathe bit deflects. And so it's cutting the whole way across, but it's not digging the whole way here. So when you're running crappy lathe bits like this, you want to make sure you keep an eye on it and get your high spots knocked all down kind of level. So I'm going to have to work on just this center a couple passes here to bring her down to this height, and then go again from there. So just something to watch out when you're doing this. Alright, only a bajillion passes later, we're finally about there. We're getting down there. You can see that center strip where the oil groove in the shaft was. Still a little bit high, but we're getting her leveled off. You'll hear it on entry here. And then you'll hear all of a sudden get quiet, and then when it gets the oil groove again, you'll hear it cutting again. Also, the downside of tool deflection of our turd of a Harbor Freight cutter, and we might have already chipped the carbide bit on it, so it ain't cutting its greatest either. As you can see, we already started to turn it down. I thought I had the camera on, but the dang thing died. But caught that it died. We had to switch out our bits anyways to get the point over, so that way we could cut up tight to this shoulder. Because otherwise you can see it's kind of tapering down, because with a bit with the angle on the left side like you normally want, I couldn't get in there. So now that we got the camera going again, alright, you can see we got her turned down quite a ways here. You can see like our low spots, and a couple spots where we got to build out a little bit more and all that. The back half we get a much better fill than the front. Yeah, got some spots we got to build up, because right now we're 2 3/8. Grab our hub here. Our hub is 2 5/16. So rather than turn this down to that size, what I'm going to do is I'm going to fill our low spots.
Alright, we got our shaft over here. Look, woo, nice clean bench. That won't last long. Turn our gas on, I bet. That helps we turn our welding mask on too. Cool it down again. We did such a good job, as you can see, keeping the shaft cool that we didn't warp it. She ran nice and true in the lathe. It'd be a shame to warp her now. Do what we've been doing, tack her up and let cool, and then tack her up again.
You can see that smoke. Well, we took a pit stop and took a break from working. Oh yeah, look at that smoke. We might have a bit of a massive burnout with our Buell because, you know what? If you don't ride a Buell, do you really ride? On a side note, back to the project at hand. We're churning this bad Betty down on the welds we did. We're gonna go kick some ass. If you can't read this, it says, doubt it, Buells don't have that kind of power. Can you believe friends would tell you that after you just said massive burnout in the shop? Truck them. Buells all the way. Getting shit done. Woo! Alright, we're back to our shaft. As you can probably tell by if you've seen any of the projects in the background here, this project here has been on the back burner, and it's probably been, 2 months on and off, just tacking, welding, here, there, willy-nilly shit. Because, you know, the stuff on the farm is far more important than getting this back together. I mean, you can deal with a woman bitching at you with her truck not running, but you can't deal with the manure lagoon, you know, not getting pumped. As you can see, we're working on the shit pump or the chopper not chopping feed. So, yeah, back burner. But guy probably could have did this shaft in an hour or two, but I took my time and just, you know, you just tack her up. You can see where I turned her down already. Just tack her up in the low spots after we turned her. Now we're going to take her back. Tack her again.
Well, I already tacked her. We're going to take her back and turn her again. You can probably also see where it got a little porous because because as I found out, as you have your rags here and you try to build the edge, something about heat, makes steam, makes your brazing walls porous. Crazy, I know. Who would have thunk? But yeah, so if you're going to do that, you're probably better tape this and slide your cooling rags back a little bit. When you try to build your edge, the steam coming off the rag interferes with your brazing weld, but what we're doing will be good enough. I'm going to take her back here to the good old lathe. As always, just slather a good amount of grease in the pilot hole, because I have a dead center. If you have a live center, you don't have to worry about that. Now we tighten it snug, and turn this side tight. Get good and snug. And down here, you just back her off a smidgen. I usually just judge it by the feel of rolling. Rolls good. Tight, just back it off so it rolls nice and smooth. Tighten it down. All day. You're on. As you can see, we ain't got no guard here because guards are for pussies, and we're getting shit done. So, fuck that. Alright, we're gonna go and turn this back down. Now we have our low spots filled in. We can turn it down to our anywhere we need to fit this hub. And what I need to do actually before we do that, I'm going to take a hone through here, because through the center, as you've probably seen, is sparking real good. It is harder than hard right in the middle. And it's, even on the lathe, I did a nice clean pass, and there's still a little upbeat through the middle. So we're going to just take an engine hone, punch it through, level her off good, measure it. Once we're done measuring it, we're going to turn this down, and put it to what it needs to be, and rock and roll.
Alright, after we honed it, looks like we're right around 2.340. Yeah, 2.340. So we'll want this to be a little less than that. Right now we're at roughly 2.365. So we got at least 25 thou to take off. We'll be real conservative. We'll probably end up taking 30 thou off and have a 5 thou oil clearance. I bet it'll be the goal. Alright, got our shaft all done. Nice and smooth. It's got just a little bit of rock. We got about 5 thousandths of clearance on either side. So she's 10 thou under, which should be great. Nice clearance, especially when we got the oil pump going and filling this with oil. That'll work good. And got a nice soft bearing material. Like I said, I'm just showing you an alternative option to saving this shaft, so you don't have to go buy one. And if you're real hairy and in a real hairy situation, like I said, you can use the oxyacetylene torch and do it, because I did it, and it's been in service and worked fine. If it happens to fail, I'll show you guys, you know, because obviously I'll have to tear it apart, but I mean, it's been going on like a trooper, and you know, who knows what using the torch on did to the poor shaft. I mean, it can't be the same temper as what it was, so it just goes to show you that the shaft itself must have been overbuilt, because I mean, it is used and abused every day pulling shit on the farm. You know, farm trucks don't have an easy life. They pull stuff that's stuck and shouldn't be pulled, and probably should have hooked down with a tractor. So, yeah, there you go. That's how you repair one of these shafts. You know, and if you cover it with rags, you get minimum overspray. I got a little nib I got to clean off there, but I mean, it works real good. Hope this helps.